This is Algebra 1, 4.5. It starts on page 229 and goes to 235. This is obviously a roller coaster, and we're going to use this to describe slope. You can describe steepness by a ratio called slope. So that's what this lesson is about. You can have positive slope where the line is going up, or you can have a negative slope where you are going the opposite direction. And to find slope, you have to divide the rise by the run. I'll explain that in just a minute. So the slope of a line, in the example here that I want to show you, it says find the slope of a hill that has a vertical rise, that's this part here, and a horizontal rise of 200 feet, and let M represent slope. So this is the horizontal run, and the red line here is the vertical rise. Horizontal run is 200 feet, and the vertical rise is 40 feet. And so you solve it with the vertical rise on top, the horizontal run on the bottom. So we have 40 feet here, we have 40 there, we put 200 on the bottom, and then we reduce that down, and we have the slope of the hill is 1/5. And once again, here's the complete formula. Slope, M equals vertical change over the horizontal change, and that's called the rise over the run. And it shows, again, the same thing here. We have the y-intercept. We can see that right there, and we can see that we have the rise is noted in this little squiggly blue line, and the run is what is across there. The y-coordinate of the point is where a line crosses the y-axis, and then it is called the y-intercept. You can see on this one that at the y-intercept, there's basically, they did this dotted line. It's 1 unit, 2 units here. Over here, it's a -1 and -2 units, so that's where they get the -2 and the 2 units. And then the line that was plotted, over here, the coordinates are -2 and 5, and over here it's just 2 and 3. And you just, with your line that goes through the y-intercept, you just go down here, and on both sides it goes, over here it goes up 1 unit, and over here it goes down 1 unit. So the slope of parallel lines, the slope of a the slope of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. So if a line passes through points which are called x1 and y1 and x2 and y2, and I'll explain that in a minute, then the slope is what we've been talking about, rise over run. And then you put it down here, you take y2 over x2, and on this side you take y1 over x1, and you're basically subtracting the 1's from the 2. So that's a little confusing, but I'll explain it in a minute. Now sometimes it's like it says here, it doesn't make sense to draw a graph. Sometimes you can use a formula to figure something out, and you don't have to graph it out or draw out all the points. In this case, we're looking at this formula, rise over run. We have y2 over x2, and then subtracting y1 and x1 from y2. In this case, you can see that we're going to look at our coordinates, because the y2 is over here, x2 and y2 over here, x1 and y1 are over here. And the 5 here is x2, so that goes there, and y2, and the x2 is 4, and it goes underneath. The y1 is over here, it is -4, and we have 3, so we have the 3 over the 4, that's 2 over 8, and equals 1/8. This is just a cute little picture, but this is what happens when the slope is positive. It's going up into this quadrant here. Now this is find the slope of a line that passes through the points 1 and 0 and 3 and 4. We have the same equation, y1 over x1 minus y2 minus x2. Okay, so I just realized that this graphic that I'm using here is incorrect. So hang on a second. So they have the ones and the twos mixed up here. It should be the opposite. The y2 over x2 should be on this side, and the ones and the x should be on this side. And so they wrote the little numbers wrong here. The problem works out the same, but it's just wrong how they marked it. And so the slope is 2, and you can see here that they plotted the 1, 0 here, and the 3 and 4 here, and then drew a line, and it's going into this quadrant, so it's a positive slope. So let's look at a couple examples here. This is x1 and y1 equals 3 and negative 5. Okay, this is not negative 5. This should just be a comma here. Let me see if I can get this. This should be a comma. That's not a negative 5 there. Okay, and then y2 and x2 and y2 equals 1 and 4. And then we work that out. We have 4 over 1 minus 5 over 3. And when you subtract that out, that is 1/2. Down here we have x1 and y1 equals 2 and 0. x2 and y2 equals 4 and 3. And we subtract the y2 and the y2 is 3. x2 is 4, we have the y1 is 0, and the x is 2. So just to make sure that you're seeing, the 3 here goes there, the 4 goes there, the 0 goes there, and the 2 goes there. So it's just kind of, it's like backwards. And that answer is 3 over 2. And another last example here. We have x1, y1 is 2 and 7, and x2, y2 is 1 and 3. We end up with 3 over 1 minus 7 over 2 equals 4 over 1, and that works out to be just 4. Now this slope is going the opposite way that the positive one, and this is a negative slope. So you can see that it's the exact opposite of the positive slope. And I just want to note, in statistics, these slopes will tell people, researchers who've collected information, what the relationship is between two things. Is there a negative relationship or is there a positive relationship? So the slope is very important and is used a lot by marketers and research companies and engineers and all kinds of people to figure out the relationship between things. So on the slope, this is talking about negative slope here. Find the slope of a line that passes through the points 0, 3, and 6, 1. Once again, they've got these on these graphics turned around. They should be in opposite of what they are, but it still works out to be the same. And in this case, you're going to have 1 over 6 minus 3 over 0. You simplify the answer, and you end up with a slope that is negative 1 over 3. Okay, let's look at these examples. For negative slope, we have x1, y1 equals 2, 4, x2, y2 equals negative 1 over 5. We plug in our data points, so we have 5 over negative 1 minus 4 over 2. That equals to be negative 3. In another example, x1, y1 is 0 and 9. x2, y2 is 4 and 7. We set up our formula. 7 over 4 minus 9 over 0 equals negative 2 over 4, and that answer works out to be 1/2. x1, y1 equals negative 2 and 1, and x2, y2 equals 1 and negative 3. And that works out to be negative 3 over 1 minus 1 over negative 2. We'll talk about that double negative there. So I rewrite my equation here, the negative 3 minus 1 on top, and over here I have a double negative here, because we had a negative here and a negative here. That's going to make a positive, and so we just end up with negative 4 over 3. This funny little guy is, he's doing a 0 slope, and it is a horizontal slope, and the slope is 0. There's not, it's just straight across. There's no going up positive or going down negative. This talks about a 0 slope. These would be examples in real life of 0 slopes. There's no decline or incline. So this is straight across, this is straight across. The table is flat, although the angle of the picture might not show it is. But you can see 0 slopes in a lot of things in life. So let's look at this. We have x1, y1 equals 1 and 2. x2, y2 equals 5 and 2. And so we put 2 over 5 minus 2 over 1 equals 0, 4. And now that is, because this is 0, then that is 0. And so the slope is 0. So when the 0 is on top, the slope is going to be 0. There's nothing that's taking place. It's just going to be straight across, although I didn't draw it so well. This shows you the difference between a 0 slope and an undefined slope. In a 0 slope, there's no x. So you just have a line that's going through the y axis. In the undefined slope, it's doing the exact opposite. It's going, there is no y in the equation, and so it's just going up and down. So if there's no y, if there's no x, it's a 0 slope. If there's no y, then it's an undefined slope. So let's look at this example. x1, y1 equals 5 and negative 1. x2, y2 equals 5 and 3. We have 3 over 5 minus negative 1 over 5. We have to set up our equation a little different because we have a negative here. So we have the 3 minus a negative here, and the 5 minus 5 on the bottom. So that turns the double negative into just a 1 there. We end up with 4, but 5 minus 5 is 0, and you can't divide by 0, so it's undefined. It has no meaning. 4 over 0 means nothing, so it is undefined. Here are the 4 slopes that I've talked about. We have the positive slope, which is going in this direction. We have a negative slope, which is going in this direction. We have a 0 slope, which has no x, and we have an undefined slope, which has no y. The 0 slope is horizontal, and the undefined slope is vertical. So your assignment for Algebra 1, Lesson 4.5, is found on 233 to 235. You'll do examples 1 through 3, 16 through 18, 21 through 25, 32 through 35, 38, 39, 45 through 59, and that's just the odds on that one. And I did want to point out just something you would see in everyday life is this ramp here, that you can see that I can get a slope from that, and then I could have done, I could work out an equation just from that. Good luck.